Okay, today we're going to do lesson 8, function notation. So the first thing I want you to do is sort of forget about this mapping notation that we did last class. It's not, it's not very common, and it's not very useful compared to the function notation that we're going to learn today. So in the function notation, we to write a function, you basically write this f followed by brackets and then x and then bracket again. So this is read f of x. The way to think about this is, if you have some sort of a function, if I throw in the x in there, remember the x is your input. So if you throw your input into some sort of a function, and the function, you can think of it as some sort of a machine. I can throw that in there, and then I get the output, and the output is what happens to your input once it goes through the function or the machine. So, and that's read f of x. So to give you a sort of funny example, if my function is let's call it Mr. Vidich. Okay, that'll be my function, Mr. V. And if I input into him food, okay, the output will be I don't know, I'll be happy. Okay, if I give Mr. Vidich money, okay, the output is he will be he will be rich. Okay, so that's sort of a funny way of looking at what a function is. So this will be my my function. We'll call it f, or you can call it anything. Any letter will be fine. Mr. V is okay. The input is food, and the output or the input is food and money, and the output is happiness, and I'll be rich if I have money. So that's kind of a funny way of looking at that. So let's go ahead and do a few examples with this. And again, go through this on your own here. Again, forget about the mapping notation and just think of the function notation, and how this is what we learned in the last few lessons, your equation notation here. Okay, so and then here's some notes here. F at x does not mean f times x. The name of the function is f. You could have g at x, you could have p at x, you can have anything you like. Okay, so that is the name of the function. Okay, let's go ahead and do some examples. So the first one, my function is f is x squared plus 5. So what this x represents here is the input. So the way you can read this is f. This is f at x. Well, f at x is x squared plus 5. Well, this is f of 3. F of 3, I'm going to input 3 into my function. So basically it's going to be, instead of the x, I'm going to put a 3 squared plus 5, which is 9 plus 5, and that would be 14. So if I input 3 into my function, I get the output of 14. G at x, on the other hand, is 4 minus x. So if I input 1 for x, I'm going to get 4 minus 1 equals 3. So g at 1 equals 3. F at 3 equals 14. Let's go back to the f1. Well, this time we're inputting -2. So I'm going to get, again, do your brackets here. So -2 squared plus 5. 4 plus 5 equals 9. G at -2. What's g at -2? Well, g at x, let's write the whole thing out. G at x is 4 minus x. G at -2 is 4 minus -2, which is 6. Okay, f at 0 minus g at 0. Well, f at 0 is going to be 0 squared plus 5 minus, let me do this in different colors so you can see it. So I'll do the g at 0 in different colors. That'll be 4 minus 0. So that'll be 5 minus 4 equals 1. Okay, so that is, this here is g at x. This is f at x. Let's look at some more down here. Consider the function f at x equals 5x cubed minus 2x, and then again x is in a real number. Okay, so f at negative 3. Let's go ahead and input 5, and then I'm every time you see you have an x, you just put a bracket, and then you stick your input in there. Cubed minus 2, again bracket because of the x, negative 3, 5 times negative 27, plus 6, 5 times negative 27 is going to be 135, so negative 135 plus 6 equals negative 129, negative 129. The value of f when x equals 2, well, that's just another way of saying f at 2 equals 5, 2 cubed minus 2 times 2 equals 5 times 8 is going to be 40 minus 4, 36. The image of 7 under f, well, that just sounds weird, but what they really want is just f at 7 equals 5, 7 cubed minus 2 times 7. And again, that's going to be some large number there. 5 times 3, 43 minus 14, and you can go ahead and do that one. An expression for f at 8. Well, you don't always have to have your inputs as numbers. Just like we input food into Mr. Vidic, we can input a into our function, and if I input f at a, I'm just going to, again, the same thing, make brackets where your x was, and all I'm going to do is input my a. Okay, and if I was going to simplify that, well, that is a simplified expression. That's all I can do. So then same thing here. If I input 2x, this gets a little bit tricky. I'm going to go again and go ahead and put in 5, and then bracket cubed minus 2 bracket for the x. So then I'm going to put in 2x and 2x, and I'm going to get 5, 8x cubed minus 4x, or 40x cubed minus 4x. Okay. Okay, moving on. We have, here's our function, p at x equals 4x squared minus 6x plus 1. Determine a simplified expression. Let me get rid of this over here. Determine a simplified expression for p of x minus 3. So what I'm going to do there is I'm going to substitute, every time I see an x, I'm going to substitute in x minus 3. So let me go ahead and rewrite this as 4, and then a bracket, squared, and then a 6 bracket plus 1. And then I'm going to input x minus 3, x minus 3. Okay. Okay, you can go ahead and simplify that. You have to FOIL this and distribute this, and I think we can all understand that from the previous unit. The key idea here is to whatever your input is. If this was p at monkey, you would have to go 4 monkey squared minus 6 brackets monkey plus 1. So you get the idea. that you can have anything as the input. All right. Okay, for this next example here, example number 4, they give you the function again. F at x is 10x minus 3, but now they want to determine the value of x if f at x is 47. So you have to work backwards now. They give you the output and you have to find the input. You have to find this. So whenever they give you the f at x, the value of f at x, you have to find out what the input is. In this case, if f at x is 47, well, that's f at x, so it's going to be 47 equals 10x minus 3. 50 equals 10x, x equals 5. Okay, so now you're working backwards. So f at 5 equals 47 if you were to do it the right way around. Solve the equation for f at x equals. So again, now what's the input when the output is negative 23? 10x minus 3, negative 20 equals 10x, x equals negative 2. So this is, be careful before you jump into doing these questions. Make sure you know the difference between looking for the actual function like p at x or f at a or whatever it is, as opposed to when they give you the output and you have to find the x itself. Okay, so you'll come across a few of those questions. Okay, let's do one more here and then we'll finish with this section. So again, what are they asking me here? They're asking to evaluate the function when the input is 4. So they want to know the output. So f at x equals x squared minus 5. F at 4 equals 4 squared minus 5, and that equals 11. Solve the equation f at x equals 4 is an entirely different thing. They're giving us the output. They're saying that f at x equals 4. So f at x, let me rewrite the whole thing, equals x squared minus 5. If f at x is 4, then this becomes the 4, the whole thing, equals x squared minus 5. What is the input? Solve for x here. I'm going to get 9 over here, x squared, and x equals plus or minus 3. Solve the equation f at t equals 75, where t is greater than 0. So answer is simple. So f at t, so if I put 75 here, it's going to be t squared minus 5. 80 equals t squared. T equals the square root of 80. Okay, simplest radical form, the square root of 80, if we all remember this, it's going to be 16, 4 root 5 equals t. Okay, and that is it. So thanks for watching and see you in class.